Hello everybody, welcome to a new video of my channel Physics with Argeo. Today we are going to solve the problem 36 of the book Physics Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Chairperson. This is the problem. Two identical unknown charges experience a repulsive force of 48 Newton when they are 60 millimeters apart. What is the magnitude of each charge? So, we have to use the law of Coulomb. F equal to K multiplying Q sub 1 multiplying Q sub 2 divided by R squared. Then, R squared is dividing, so it must multiply in the other side. So F multiplying R squared is equal to K multiplying Q sub 1 multiplying Q sub 2. Then K is multiplying at the right, so it must divide at the left. So F multiplying R squared divided by K is equal to Q sub 1 multiplying Q sub 2. But the electrical charges are identical, so Q sub 1 multiplying Q sub 2 is equal to Q squared because they are identical. So, applying the square root at both sides of this equation, it gets the square root of F multiplying R squared divided by K equal to Q divided by K equal to Q. Now, the square root of 48 Newton multiplying R squared is 60 millimeters. So 60 times 10 raised to the power of negative 3 meters squared. This divided by K, and it has a magnitude of 9 times 10 raised to the power of 9 Newton meter squared divided by Coulomb squared. It's equal to the square root of 60 squared 3600. 10 raised to the power of negative 3 squared equal to 10 raised to the power of negative 6 meter squared. Now, this multiplying 48 Newton, and this divided by 9 times 10 raised to the power of 9 Newton meter squared divided by Coulomb squared. This is equal to 48 multiplying 3600 multiplying 10 raised to the power of negative 6 divided by 9 times 10 raised to the power of 9 Coulomb squared. Now, 48 multiplying 3600 is equal to 172,800 divided by 9. And negative 6 minus 9, negative 15. So 10 raised to the power of negative 15 Coulomb squared equal to the square root of 172,800 divided by 9 equal 19,200 multiplying 10 raised to the power of negative 15 Coulomb squared equal to the square root of 192,000 multiplying 10 raised to the power of negative 16 Coulomb squared equal to 80 times the square root of 30 multiplying 10 raised to the power of negative 8 Coulomb. Now, this is the magnitude of the electrical charge Q. So, I supposed that the two identical unknown charges now have a magnitude of 80 times the square root of 30 multiplying 10 raised to the power of negative 8 Coulomb. we have to check it. So, using the law of Coulomb, F equal to K multiplying Q prime divided by R squared, I get 9 times 10 raised to the power of 9 Newton meter squared divided by Coulomb squared. But here appears a purple, the symbol plus minus, and here it appears again, for the reason that this is the magnitude of the electrical charge, but in the hypothesis it says that the two charges are identical. So the force is a repulsive force. So minus gives a repulsive force, and plus gives a repulsive force too. So for this reason, this symbol appears here. So plus minus 80 times the square root of 30 multiplying 10 raised to the power of negative 8 Coulomb, multiplying by itself, open parenthesis, plus minus 80 times the square root of 30 multiplying 10 raised to the power of negative 8 Coulomb, closed parenthesis, is equal to 6,400 multiplying 30 multiplying 10 raised to the power of negative 16 Coulomb squared. This divided by the square of the distance. So 60 multiplying 10 raised to the power of negative 3 meter squared is equal to 3,600 multiplying 10 raised to the power of negative 6 meter squared. Now 6,400 multiplying 30 equal 192,000. Multiplying 10 raised to the power of negative 16 Coulomb squared. Divided by this same number in the denominator. And multiplied by the constant of Coulomb K. 9 times 10 raised to the power of 9 Newton meter squared divided by Coulomb squared. Now, multiplying 9 by 192,000 is equal to 1,728,000 divided by 3,600. Now, the product of the exponents is the next. 10 raised to the power of 9 multiplying 10 raised to the power of negative 16 is 10 raised to the power of 9 plus minus 16, and this divided by 10 raised to the power of negative 6. Coulomb squared divided by Coulomb squared equal 1. Meter squared divided by meter squared equal 1. So the unit is Newton. This is equal to 1,728,000 divided by 3,600 equal to 480. Multiplying 10 raised to the power of negative 7 divided by 10 raised to the power of negative 6 Newton equal to 480 multiplying 10 raised to the power of negative 1 Newton equal to 48 Newton of repulsive force. Now, look at this. 84 Newton of repulsive force is the same repulsive force of the hypothesis of the problem. So, this means that the distance that I found is the correct distance. So, the electrical charges must have a magnitude of 80 times the square root of 30 multiplying 10 raised to the power of negative 8 Coulomb each other, and they must be separated by a distance of 60 millimeters. And then the electrical force generated is a repulsive force. So, students, it was the problem 36 of the book Physics, Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in chairperson. In the next video, I'm going to solve another problem. Thank you for your attention and study a lot.